Hello everybody and welcome to Kaggle Basics. This is the first video. It's just going to be a basic display of what you can do with Kaggle and how Kaggle works, and just a basic introduction to data science and how to navigate the Kaggle website. So right here we can see the Kaggle website. We have home, competitions, data sets, code, even courses down here. You're going to want to make an account. I'm not sure how to make an account. I'm sure it's not difficult. I made one about a year ago. So it's not a complex process. Just make an account. And then after that, you can do some courses. A prerequisite to this video would certainly be a basic understanding of Python and pandas and basic statistics in machine learning. Once you have all of this set up and you feel comfortable that you can tackle a data set, you can click here and go to competitions. And basically all of these competitions are just data sets, and each one of these data sets have a certain thing that you would like to predict. If we look at a few of them, here's H&M, personalized fashion recommendations. That's probably use your data and then pick out what type of fashion items they would want to buy, so that H&M could advertise in an efficient manner to people who want to buy stuff. You got March Machine Learning Mania right here, so that's March Madness basketball. Predict the winners probably. I'm sure it has to do with player stats and location of the game. I bet there's a bunch of different data you could come up with in there. To get started, if you're just now getting started with Kaggle and you want to start playing with some of the beginner data sets, some of the best beginner data sets are the Titanic, the digit recognizer, and house prices. So Titanic is user data for people who boarded the ship, and it's kind of gruesome, right? It's whether they live or die. So you're predicting based on their gender, what type of ticket they bought, because they might be in the top of the ship or in the bottom of the ship, and you basically predict whether or not they survived the crash. But that's a very popular one. Digit recognizer is a pixel. I think it might be the MNIST dataset, but it is a 28 by 28 pixelated image, which we can look at, and you have to predict the what digit it is based on the numerical value of each pixel in the image. We can look at it real quick. So each and this was actually used on checks, I think, so that computers could read checks in the 1980s or possibly the 1970s. Yan LeCun. Yeah, so that's a good one to start with as well, because you could use so many different types of machine learning on it. But the one I want to start with is the housing prices data set. So here it is. This is the housing prices data set. It's a data set with a bunch of different houses, all from Ames, Iowa. I think Ames is in Iowa, right? The Ames housing data set. Well, I'm pretty sure it's in Iowa. And you have it's all tabulated data. You can go to data and look at it. Here's data description text. You can download that. I have it right here. So this will give you basically a rundown of each of the types of data, each of the categories there, and that's basically it. What type of house it is. It goes through each one. Overall quality, overall condition, year built. So we're going to take all this data and try to predict what the cost of the house is. That's the game, right? It's always a game. Test SCV, that's all the data kind of columnized in Excel format. .csv, that's an Excel format, so we can see the lot frontage. You can scroll down over here. Street, it looks like there's a lot of pave. Alley, lot shape, blah, blah, blah. So you want to get started, you go to code. And with these popular data sets, it's very easy to find a good code to use and just learn from their code. You don't want to just go write your own code to start off. That's going to be super impossible. So go to code, and then you click over here on this. It says hotness, which I don't know what that means. I guess that means recently viewed or something. But you don't want that. You want most votes, maybe most comments, maybe best score. Most votes is going to be good for beginners because that means that a lot of people liked it. This guy's got a ton of votes. So he probably made a very easy to understand code here. So we can click on that. I've already started a copy, but I think you can hit copy and edit notebook. That should be right here if you haven't made your own copy yet. And basically what will happen is you'll take this guy's whole code and copy it over to your GUI on the Kaggle website. You can run all of these codes on Kaggle's website, whether you have a really good computer or not. You don't need to have a good computer. You could be using a laptop or even an iPad or something like that and be perfectly capable of doing it. So let me go here. I'm going to hit edit my copy. And now I'm in my code. This is my version. It's just a copied version of his code. I can change the name of it. I could change it to housing prices PW, and I could access this later. But essentially, I'm just going to run it. So it's very well. It's done by Pedro Marcelino. It's very well documented code. There's a lot of explanation, which is very good. But let's just go through it real quick so you can get an idea of how to use someone else's code and learn from it, especially when they make a great tutorial like this. It's just a really convenient thing to have. So right here, I'm not going to read everything that he wrote, but this is a very good little blurb right here. Number 1, understand the problem. Number 2, univariable study. Number 3, multivariate study. Then basic cleaning, and then test your assumptions. And that's all we're going to do. We're not going to do anything too complicated. Just get a basics for navigating a data set using pandas, matplot library, Seaborn, and NumPy, SciPy, sklearn, all of these different modules that are part of Python are what we can use to analyze this data and get a better understanding of this data, and also finally analyze the data, get a better understanding of the data, and start making predictions from the data. That's the ultimate goal. So you click in this box here and you hit shift enter, hold down shift, hit enter, and that is running the code. Session is starting, so it's actually going to take a minute to start the session. This line of code shouldn't take that long, but right now it's booting up. Essentially, we're logging into the online mainframe of Kaggle and running it on their computers. It's like cloud computing, basically. So another thing we can do is if you go here, you can turn your accelerator to GPU, but you have to understand that you only have a certain amount of GPU time per week. Let's see. GPU weekly time Kaggle. 43 hours. It says between 36 and 43. So I don't know how they determine that. But that's a lot. That's a lot of hours. I mean, you're probably not going to be coding that much until you get really good. And the other thing is you don't need it. I'm not going to turn it on, so I won't use it at all. This code is not a very complex convolutional neural network that requires GPU processing. It's very basic, so let's just keep running through it. So if you see that 1 here, that means that this line of code has been run. This is very similar to the Anaconda Python. So if you're familiar with Anaconda, this should not be difficult to do at all. Let's shift enter this and run it. So we just inputted the data set, the training data set. We read it using pandas, read _CSV. Now we have all of that in. and this is how we were able to access the train CSV, since that is already basically built into this. I guess you would say code, or you don't. If you download this code and run it on your own computer and don't run it on the cloud, then you would have to specifically name where the file is on your computer, and you would have to download all of these modules and make sure that the correct version is on there. So it's much easier to just run it on. Let me fix my camera a little bit. It's much easier to just run it on on the cloud. So let's keep going. Now we're going to look at the columns. This is all the different types of data. MS subclass, zoning. I'm sure there's sale price is what we want to predict. You got pool area, kitchen quality, first floor square footage, second floor square footage, all these different. It's like 60 or 70 different categories of data. So what can we expect? Now he gives us a little assignment here. You can do it if you want. I think it's beneficial. I did it. So you type out all the variables in an Excel spreadsheet. You identify it. Is it numerical or is it categorical? That's an important distinction, and it's not very difficult to determine between the two. If we pull up the data description, let's just look at the very first one. Type of dwelling involved in the sale. Is it first story, 1946? This is categorical. It is stored in a numerical fashion, but it is categorical data. So that might be a little confusing, but it shouldn't be that confusing. The 20, 30, 40, 45, 50, that all indicates what category it belongs to, and here's the wording of that category. Is it a duplex? Is it a first story, second story home? Anything like that. Zoning, this also looks like it's categorical in nature. Cooper, no. Shh. Categorical in nature. Here we go. Here's numerical. Lot frontage. Linear feet of the street connected to the property. So I did this. Let's see what I wrote. Variable description. Lot frontage, I wrote numerical. Okay, so I got that right, it looks like. And then it goes through, and red indicates whether if you think it's important or not. Let's go back to the code. Go back to the code real quick. Boom. Get that out of here. Type, is it numerical or category? And then segment it. Now here he's talking about, it's a good exercise. I don't know how necessary it is, but building would mean that it relates to the building. Space means that it relates to the space properties of the house. And location is the greater location in the Ames, Iowa area. So building has to do with house. Location has to do with its location in the city. And then space, what does space have to do with? I guess actual space properties of the house. That's like square footage and stuff like that. Okay. So you can take the time and do all that. I did do that. It's fine, Then you want to predict what you think is a big predictor. Looks like I chose MS subclass as a big predictor. Predictor means that it should have a very strong relationship with sales price. Building type, neighborhood. I think that neighborhood should be a good predictor of price. Overall quality and overall condition, which is, as the author of this code points out, kind of subjective data, so it's interesting to know how do they determine that. I mean, it's probably easy to determine like which quality is better between a rank 10 and a rank 1 house, but how do you decipher between a 9 and an 8? It's a subjective quality. You're rating a house on a 1 to 10 scale, so that would be interesting to know how they did that. Year built, I didn't say that's super important. You only pick a few. Greater living area, that's square footage. Kitchen quality, garage type. I put all of those as good predictors. So let's keep going through the code, and then we'll see that. He picked a lot of the same ones I did. except he also picked total basement square footage. I didn't pick that, but I live in Florida. There's no basements here. Maybe in Ames, Iowa, people really care about, how big's your basement, man. That's a big deal. Now let's go to sale price. Let's look at that. This dot describe command is going to show us the number of total houses, I guess, would be, how much data total you have. And in this case, it's houses, 1,460. The mean price, the standard deviation, the minimum cheapest house was 35,000. Very cheap. Wow, it's like a car. Max was 755,000, which isn't even that high, but I guess because it's Ames, Iowa. So, and then 50%, top 25 or bottom 25, and 75%. Just breaking it out and getting a good idea of what the distribution of the better way would be to plot it, and I think that's what he does next. So histogram plot the sales price, and now we can start drawing some conclusions from this data. And this is where you got to kind of be a little data sciencey and figure out what's going on with it. So in this case, this is not a normal distribution. This looks a little bit skewed, which is a technical numerical term. That's not just a subjective description. That's something we can measure. And it deviates a little bit from normal distribution. That's what he says. Shows appreciable positive skewness, shows peakedness. I'm not sure what that means. And deviates from a normal distribution. Normal distribution, let's look at that. Here we go. This is a normal distribution. And our distribution does not look exactly like that. It's not a perfect normal distribution. So here we go. So that's our first conclusion from this, and we're starting to learn a little bit more about our data, and that's good. Now we keep going here. We can actually measure the skewness and the kurtosis of it. Now, skewness is not hard to understand. It's how far skewed to one side it is that you could get a better mathematical understanding of that. Let's type in kurtosis and see what that is. That is the fourth central moment over the standard deviation. That's not super important to know what that is. Let's look at this picture because this should explain it pretty well. Positive kurtosis, negative kurtosis, and a normal distribution. So a positive kurtosis means that it's a very high peak. Negative means it's kind of spread out. So if you look at ours, it should be a positive kurtosis, right? Because let me just can't get out of this one. I keep messing that up. Because it's a very high peak. So that's kind of what kurtosis is. This would be negative kurtosis if it's a very flat and drawn out one. And that kind of gives you an idea of how to describe a distribution a little bit. It's not a big deal if you don't know the exact formula for calculating kurtosis and skewness, but we can put a numerical value on that. So skewness is 1.8 and kurtosis is 6.5. That means that it's displaying a lot of kurtosis. Now he's got a bunch of, he like compares this to like meeting a girl or something. You can read all of it if you want. It's fine. You don't have to though. Now let's look at the relationship. This is a very important part. It's kind of the first step. Let's plot it, scatter plot it, look at it. Not too difficult to understand, right? Here we have on the y-axis sale price, on the x-axis greater living area. Greater living area is, if that's what it means, it's GR live area. It's the amount of square footage above the ground. So basement not included, everything above the basement. Looks like a linear relationship. That's what he says here. Looks like a linear relationship. You got a couple of outliers, but mainly linear. Okay, let's keep going. I think I actually added this in. So this wouldn't be in the code, but it's fine. I'll show you how I did it. It's not hard to do that. I was just kind of playing with it. Overall quality. Okay, so overall quality was that integer number from 1 to 10. It looks like only 2 got a ranking of 1, so they must have been really bad. And then another 2 got a ranking of 2. And then these are stacked pretty heavily. And we can see a little bit of a, not exponential, what is that, like an inverse exponential relationship? Maybe linear. I mean, whatever you want to say. It's hard to determine the relationship here, but certainly as the quality goes up, the price does go up. Total basement square footage. Okay, so some of them don't have a basement. Looks like we're dealing with another linear relationship with a couple of outliers. So if I click here and I hit A, I add in a block of code above that. I can take this whole thing, Control C, Control V, put that in. Now I can plot whatever. I don't have to just blindly follow his code. I can look at some other things that I want to look at. What would be one of those things? Let's find a numerical value since that. Let's do overall condition. Did I do that? I think I did overall quality. Let's do overall condition. Plot that. Wow, that's an even worse relationship to determine. Let's plot another thing. Got to be numerical since we're doing a scatter plot here. Second floor square footage. Put it right here. Shift enter. Okay. A lot of them don't have a second floor. But the ones that do, the bigger the second floor, it looks like a linear relationship, price will go up. So we can just look at all of the different relationships there. Now we can go forward and look at some of the relationships with categorical features. So I guess technically overall quality, he determines that to be a categorical feature of the property, which I guess is true. It is kind of a abstract number, but it's still a number. But he says categorical, so let's run that. Shift enter. Now what we did here is we box plotted it. So remember when we just plotted it in a scatter plot? That's not very good. You can't get a lot of detail from that. If we look at it in a box plot format, you can get a lot more detail. And what this box plot is showing is top 25% here, upper middle 25%, lower middle 25%, bottom 25%. Outlier, outlier. Dots are outliers. So these it's a bot and whisker plot, I believe is what it's called. The box shows 50% of the data. The whiskers show the other 50% of the data. Whether it's on the upper side or the lower side of it. So you can kind of get a distribution kind of feel for the overall qualities of the house. Let's look at, that's quality. Let's look at condition. It doesn't, not a good predictor almost. I mean, some of these, it's hard to tell the difference between 6 and 8. So however they got those numbers, it doesn't look like it's a direct predictor of price, overall condition. I mean, this 3 gets all the way up to 200,000. 4, not even as much. 5 has a huge distribution. Yeah, so that's just kind of to show you how some of your data can be a little bit messy. And this is the first process when examining a data set, is looking at each of these variables and determining how good of a predictor they are of your target variable being price in this case. So now let's look at year built. Sure, this one's definitely going to be messy, right? Yeah, so year built from 1872 to 2010. Not any given year is going to show you a great deal. We're not seeing that prices go up as they get newer. Maybe slightly. After the 1990s, they go up a little bit. Certainly the top end of those distributions is higher. But not a great predictor And that makes sense to anyone who's probably looked at or purchased a house. Sometimes the older houses are built better than the newer houses, but there's a ton of variables in there, right? The quality of the roof, the HVAC system that's installed in the house, the plumbing. Maybe if it's an old house, you have to replace the plumbing. Maybe it's made from cinder block and built sturdier than a newer house would be, because they start skimping on cost to build it as cheaply as they can, almost in some cases. But certain stuff has to be replaced. So year built it's not like a car. But that's basically what this plot is showing us. So keep calm and work smart. Now let's look at a correlation map, heat map style. I believe I've seen this referred to as a confusion matrix. Let me see. Let me see if I can type. So confusion matrix actually has the number in there, so it's easier to kind of see, like if there was just 10 things. But let me explain what it is. It's not difficult. The lighter the color, the more those two variables are correlated. So if we look at sales price, that's the one we're super interested in, is sale price. The best predictor of that is whatever this one is, this light color. Overall quality, best predictor. So there you go. Other ones that are good predictors is this light quality, greater living area. This one's pretty light as well. Total basement square footage, first floor square footage. So some of those are like repeat variables. First floor square footage and greater living area are certainly related. The darker the color, the less relation they have. And the reason that you see all this white diagonal down the line is because that is that variable. So ID, or let's not even look at ID, sale price to sale price, it's directly related. It's the same number compared to the same number. So of course you'll see this white line through the top. Yeah, there's a lot of the best predictors are year built, overall quality, garage cars, garage area. So those are two other overlapping variables. But the best one is overall quality. That seems to have the best relationship with it. And, year built isn't the best predictor. That's why it's not a white color. It is a gray, so it's like a 50% correlation to it. So this just gives you a good idea of what variables you want to use or weight heavier when you're predicting it, predicting the price. Let's keep going. Oh, so now we take the most important ones, and this is a confusion matrix, right? Does he call that? He still says correlation matrix, but it's the same thing. Let's see. Sale price is right here. So the order of impact that each of these variables have is overall quality, greater living area, garage cars, garage area, total basement square footage, first floor square footage, number of full baths, total rooms above ground, and year built. And some of those variables overlap. So this plot is a very information dense plot if you know how to read it. And if you're able to produce plots like these from your data set and whatever you're analyzing, and you're able to present it and explain it, that would be very good. Very good. So let's keep running. Keep running some code here. Let's do a scatter plot of all of these. That's what this is going to be. It looks like we're scatter plotting a whole bunch of different stuff. Yeah, here we go. So I've never seen this code before, but this is a pretty convenient thing to do here. We're just scatter plotting. Here's the y-axis and the x-axis, and you get the relationship between sale price and year built right here. sale price in full baths, sale price in total basement square footage, and even other weird relationships that you might not care that much about, like year built and total basement square footage. So as time went on, it looks like maybe total basement square footage kind of went up a little bit. Garage cars versus greater living area. Just all of these different, they all show two things plotted against each other. So you can use that. The main thing you care about is sale price. So sale price versus sale price, that's a 1-to-1. That doesn't give you anything. But sale price to overall quality goes up. We've already plotted that one. But you can see here, this is another very data intensive plot. And this is a line of code that you probably wouldn't be able to just write from memorization, but you can take this and apply it to your data set or whatever you're interested in and reuse it, and that's fine. Or even change it. You can edit it and change the different variables that you want to look at here. So this is how you kind of take someone else's work and build off of it and use it as a starting point rather than just going and typing your own code. That's going to be really, really difficult, especially if you're just starting out. Missing data. What do we got missing here? Pool quality is missing. So why do you think that's missing? That's easy, right? Missing data also, we should talk about that. That's very, very important to see what data is missing, what data is corrupt, why it's missing, and that gives you a really good idea of what's going on with your data set and what you can use to make up for some of these things. So pool quality, there was only 1,460 houses in this data set, so 1,453. My guess is that only 7 of these houses had a pool. It is in Iowa, so probably not that many pools going on. It's not like Florida. So 99% of the data is missing there. That's because there's no pool. So you can't rate the quality of a pool if it's not there. Let me make sure that I'm right on that. Control F, pool, QC. Pool quality, yeah. So NA is no pool. So that's why it's missing data. Miscellaneous feature. Missing. Garage type. 81 of these houses don't have a garage. Is what it looks like there. Basement variables. That looks like 38 are missing a basement. And then for some reason, this one only missing 37. So who knows? But they all have their own reason why this data is missing, and we need to figure that out and see if it's something that affects it. In most cases, it looks like it's just because that particular house doesn't have a fireplace or a fence or a pool or a garage. So continue on down. Now we're going to actually do some predicting, it looks like. No, we're going to be dropping the data here, missing data. So we just drop all the data. That's does he describe why? He just says delete it. I mean, that's fine. In some cases you might not want to do that, but we're just learning. So in this case, let's just delete all the missing data. Outliers. Another big problem. If we go back up, we can see that there were 2 major outliers here. One's right there, but this is basement square footage. I'm talking about this plot. This house has 5,500, maybe 6,000 square footage, and it is priced at $200,000, which is amazing. I don't know how that's possible, but that's why it's an outlier. Something must be going on with that. This one has 4,600, and it's also priced under $200,000. I mean, it's Iowa, but still, that's a big outlier for this. It doesn't follow this linear relationship, this nice linear relationship that we have here. So sometimes it's good to just delete those since they're going to mess up your predictive capabilities. because they're just not fitting in with the norm. Now we do a univariate analysis. Standardize the data there. Run a few more lines of code here. Let's now let's go back through it. So this univariate analysis is how you get rid of some of these outliers by determining how far outside the range they are. If we go back to the normal distribution, if you're more than a standard deviation away from the mean, and if you're 2 or 3 standard deviations away, then you're an outlier. You're what's classified as an outlier. So you want to get rid of those. This is a good plot showing, you can learn so much from just the normal distribution here. 1 standard deviation, 2 standard deviation. If you're 3 standard deviations away, then you're a big outlier. So sometimes it's good to just look at those and get them out of your data set if they're just going to mess stuff up. Bivariate analysis. Okay, so now we're going to look at 2 different things. Run that. We're plotting sale price versus greater living area, above ground living area. Deleting some of the points here. So we're deleting the 2 special cases. So he's literally calling out those 2 numbers, 1299 and 524. If we pull those up, test CSV. You can, if it's hard to navigate data sometimes, it's not hard to navigate it in Excel. So you can use Excel to kind of, while you get good at it. So 1299 and 524. Let's look at those. Let's just look at 1299 actually. I bet this is the outlier. Built in 1990. Where's sale price here? Greater living area, like at least okay, here's greater living area, AU. No, that wasn't the outlier I was looking for. Oh, maybe it was because the basement. Huh. I'm not sure why this. Let's go back to the code. He deletes these 2. The 2 observations in the top plot are those 7 something observations that we said we should be careful about. He calls those out by names and deletes them. Greater living area. So he's talking about these 2. For sure he's talking about these 2. The 2 highest square footage houses. And he's just going to delete those right off the bat. That's what that line of code is doing. Let's go back to that line of code and look at it so I can explain why I know that that's doing that. variable greater living area. So they're gone here because I deleted it. But if we look here, the top two, ascending equals false. So this means the top two, sort them and take out the top two and then drop those ones. And now they're not there. So this makes the plot much better. So that's all he's doing here. And if you read it, it might even seem more clear than my explanation there. But this is how you learn how to navigate these codes and write it better. But he's basically sorting the values from ascending and taking the very first two and then deleting them. And then when you replot it, we no longer have those two outliers. Okay, getting hardcore here. Plot this. How did we go from this distribution to this distribution? This is the biggest thing in statistics that you can do, and it certainly takes some time to understand it. But to increase the linearity of your plot, all we're doing here is applying a log transform. And that's what he does here, log transform, NP log, so a logarithm to the sale price. And then when we look at that, look at how much more normal that distribution is by taking the logarithm of it. And it's a weird mathematical thing that we're able to do, and it's not very intuitive. But by taking the logarithm of the price of house, so now that's going to make it a lot lower, right? I mean, even if you don't know what a logarithm is, you know it takes in a big number, it makes a smaller number. Let's just put it at that. And it goes from 10 to 14 now. So it's a much smaller range than what the original sale price was, but look how normal this distribution is. This black line is an overlapped normal distribution. The blue line is the actual data. It's very close. So now we'll be able to predict stuff a lot better by using that. And this line the shows the linear relationship. So the closer it is to that red line, the better it is. So it's very fascinating that's the case, and very unintuitive as well. But that's a big part of machine learning, and a big part of statistics in general is just being able to do these small tricks, like taking the logarithm of it, to be able to exploit your data set and make more accurate predictions. And that's what he does here. And it's just this one small line of code. And now look at this distribution. Much better, much easier to work with. Much better to get predictions from. And he doesn't go too far with this. The next video will go further. He's doing it to all of them now, right? All the different variables. Has basement, doesn't have basement. I just want to see his final prediction here. I'll go through the rest of this in the next video, and because this video's gone over, it's about to hit 45 minutes. I don't want it to be longer than that. And I'm also going to jump into the next lesson as well. So we'll talk a little bit more about homoscedasticity and finish up what he actually predicts here. And dummy variables is a really important topic as well, so I want to get into that. But the next video we will look at somebody who predicted. So let's go to competitions. Housing prices, code, sort by most votes. And if you look here, this guy got top 4% on the leaderboard. his code is not that complex to understand. So in the next video, I'm going to go through the rest of this guy's code, which isn't much more, and go through this code, which will be a little bit more advanced. Okay, thank you for watching.